RF interference is a significant concern in automation systems, and minimizing its impact is crucial for reliable operation. One effective strategy is to ensure that controlled devices are not on the same electrical circuits as equipment that generates radio frequency interference. This physical separation helps to isolate the automation system from potential sources of noise and disruption. The reason for this is rooted in the nature of electrical circuits and how interference propagates. When devices share a common circuit, any electrical noise generated by one device can easily travel along the wiring and affect other devices on that circuit. This is especially problematic for sensitive automation components that rely on clean, stable signals to function correctly. Radio frequency interference can manifest in several ways within an automation system. It can cause erratic behavior in control devices, leading to unpredictable performance. It can corrupt data transmitted between different components of the system, resulting in errors and malfunctions. In severe cases, it can even damage sensitive electronic equipment. Therefore, implementing effective measures to mitigate RF interference is essential for ensuring the long-term reliability and stability of automation systems. Separating circuits is a fundamental step in this process. By dedicating separate circuits to controlled devices and potential interference sources, you create a barrier that reduces the likelihood of noise coupling. This involves running dedicated wiring from the electrical panel to each set of devices, ensuring that they do not share a common neutral or ground connection. In addition to circuit separation, there are other techniques that can be employed to further minimize RF interference. Shielded cables can be used to protect sensitive signal wires from external noise sources. These cables have a conductive layer that surrounds the inner wires and is connected to ground, effectively blocking electromagnetic radiation from reaching the signal conductors. Filtering devices can also be installed on power lines and signal cables to remove unwanted noise frequencies. These filters are designed to attenuate specific frequency ranges that are known to cause problems in automation systems. Proper grounding techniques are also crucial for minimizing RF interference. A well-designed grounding system provides a low-impedance path for noise currents to flow back to the source, preventing them from circulating through the system and causing interference. This typically involves connecting all metal enclosures, equipment chassis, and cable shields to a common ground point. Furthermore, the physical layout of the automation system can also play a role in minimizing RF interference. Sensitive components should be located away from potential noise sources such as motors, transformers, and radio transmitters. Signal cables should be routed away from power cables to prevent inductive coupling. The use of surge suppressors can also protect automation equipment from voltage spikes and transients, which can sometimes be a source of RF interference. Regular maintenance and inspection of the automation system are also important for identifying and addressing potential sources of RF interference. Loose connections, damaged cables, and failing components can all contribute to noise problems. By proactively addressing these issues, you can prevent them from escalating and causing more serious problems. When troubleshooting RF interference problems, it is helpful to use diagnostic tools such as spectrum analyzers and oscilloscopes to identify the source and frequency of the noise. These tools can help you pinpoint the specific equipment or wiring that is generating the interference. Once the source of the interference has been identified, you can take appropriate steps to mitigate it, such as replacing the offending equipment, rerouting cables, or installing filters. In some cases, it may be necessary to consult with an electrical engineer or RF specialist to resolve complex interference problems. They have the expertise and equipment to perform detailed analysis and recommend effective solutions. It is also important to consider the environmental factors that can contribute to RF interference. For example, lightning strikes can generate powerful electromagnetic pulses that can disrupt automation systems. In areas prone to lightning, it is important to install surge protection devices to protect equipment from damage. Industrial environments with heavy machinery and welding equipment can also be sources of significant RF interference. In these environments, it is important to use robust shielding and filtering techniques to minimize the impact of noise on automation systems. In summary, minimizing RF interference is essential for ensuring the reliable operation of automation systems. By separating circuits, using shielded cables, installing filters, implementing proper grounding techniques, and following good layout practices, you can significantly reduce the impact of noise on automation equipment. Regular maintenance and inspection, along with the use of diagnostic tools, can help you identify and address potential sources of interference before they cause problems. In addition to the points already discussed, it's also worthwhile to consider the types of equipment that are most likely to generate RF interference. Variable frequency drives, or VFDs, which are commonly used to control the speed of motors, are a notorious source of RF noise. They use pulse width modulation techniques to vary the voltage and frequency supplied to the motor, and this switching action can generate significant electromagnetic radiation. Switching power supplies, which are used in many electronic devices, can also be a source of RF interference. These power supplies use high-frequency switching to convert alternating current to direct current, and this switching action can generate noise. Arc welders are another common source of RF interference. The arc created during welding generates a broad spectrum of electromagnetic radiation. Radio transmitters, such as those used in wireless communication systems, are obviously a source of RF energy and can interfere with nearby automation equipment if not properly shielded or located. Even seemingly innocuous devices like fluorescent lights can generate some level of RF interference. The ballast used to ignite and regulate the light can produce electrical noise. Therefore, it's important to be aware of the potential sources of RF interference in your environment and take steps to mitigate their impact on automation systems. When selecting equipment for automation systems, it's important to choose devices that are designed to minimize RF emissions. Look for equipment that complies with relevant electromagnetic compatibility, or EMC, standards. These standards specify limits on the amount of RF noise that equipment is allowed to emit. It is also important to install equipment properly, following the manufacturer's recommendations for grounding, shielding, and cable routing. Incorrect installation can significantly increase the amount of RF interference generated by equipment. Consider the specific needs of the automation system when designing the electrical infrastructure. For example, if the system is critical and must operate reliably even in the presence of high levels of RF noise, it may be necessary to use more robust shielding and filtering techniques. It may also be necessary to install a dedicated grounding system for the automation equipment. In some cases, it may be beneficial to use fiber optic cables for data transmission. Fiber optic cables are immune to RF interference, as they transmit data using light rather than electrical signals. This can be a good option for long cable runs or in environments with high levels of electromagnetic noise. Regular training for personnel who install, maintain, and operate automation systems is also important. They need to be aware of the potential sources of RF interference and how to mitigate their impact. They also need to be trained on the proper use of diagnostic tools and troubleshooting techniques for identifying and resolving RF interference problems. Furthermore, keep detailed records of all changes made to the automation system, including equipment upgrades, wiring modifications, and grounding improvements. This documentation can be invaluable when troubleshooting RF interference problems, as it can help you identify the root cause of the issue. In addition to the technical aspects of minimizing RF interference, it's also important to consider the regulatory requirements. In many countries, there are regulations that limit the amount of RF noise that equipment is allowed to emit. It's important to be aware of these regulations and ensure that your automation system complies with them. Non-compliance with these regulations can result in fines or other penalties. Staying up to date on the latest technologies and best practices for minimizing RF interference is also important. The field of electromagnetic compatibility is constantly evolving, and new techniques and technologies are being developed all the time. By staying informed, you can ensure that your automation systems are protected from the effects of RF noise.